Right. Well, the last sum for this practice. Breathe in, out. Get the oxygen into your brain, right? And when you get it right, you feel so good that you are moving somewhere in the field of coordinate geometry. Now, if we read the sum, they tell us that ABC is a triangle, and they've given us the points A, B, and C. And they ask us what sort of a triangle is that. Now, I know you can draw the picture if you want to, but let's get a mental picture, I think, to be safe, right? Okay, we draw this axis, and we said ABC. A, you're minus 2 and 5, x minus 2, minus 5. Just write it, because we are not doing a graphical representation. We're just having a mental picture. That's your A. Your B is a minus 1, your x is a minus 1, the y is, minus 1 is here, right? X, y, minus 1, and your y is a 4, right? So that's your B, minus 1 and 4, and your C, your x is 3, your y is 1, all right? Somewhere here, x is 3, y is minus 1. All right, then join them like that, and you tell yourself, well, this diagram does not tell you anything much, all right? But you just wanted to get a little bit of a direction to help you. But it is not really necessary sometimes. Now, to know the type of triangle, what are the types of triangles that you have? Isosceles. What is isosceles triangle? Isosceles triangle, well, two sides are equal, yes. Okay, the two sides are equal, the base angles are equal. The other one, equilateral triangle, yes, an equilateral triangle. You have all three sides equal, and all these, the angles are equal. Each of them are 60 degrees. And the other one is a scalene triangle, where it is just all sides are not equal. All right, we call it a scalene triangle. And let's not forget, we can get an obtuse triangle if this angle is big. An isosceles triangle can be an obtuse triangle. So can a scalene triangle be. We also can get a right angle triangle. All right. Equilateral cannot be right angle, right? You know why? Because the angles are all 60 degrees. You don't have a 90, yes. You don't have it. But an isosceles triangle can be, yes. These two sides can be equal. Of course, this will be called the hypotenuse, the side that's facing the 90 degree. Now we look at the sum and we say we want to find out what is the best way. Let's find the length of A and B. Yeah, I think you're an expert in that right now. We know we play by drawing just 2 points, A, B, or B, A, minus 1, 4. Look at A, 2, and a minus 5. A, B. What is the distance? Let's draw the right angle to see the distance from minus 1 moving to 2, minus 1, x to x, minus 1 to 0, 0 to 2, 3 units. From minus 5 moving to 4, minus 5 to 0, 0 to 4. All right, we get 9 units. So the length of AB, what's the length? 81 plus 9, 81 plus 9, the square, 90. The square root of it is 90. All right, you've got the length of AB. Let's leave it aside. Let's find the length of BC now. We said, hey, you, square root of 90, your length. All right, we've got that. Now we look at BC. We write BC down, and we said, oops, write it down. B and C. You got a minus 1 and a 4. You get a 3 and a minus 1. Now draw the right angle. Minus 1 moving to 3. How many units is that? Minus 1 to 0. 0 to 3. Minus 1 to 0 is 1 unit. And from 0 to 3 is 4 units. So that's 4. Minus 1 moving to 4. Minus 1 to 0. 0 to 4, that's another 5 units. So you got 25 plus a 16. What will that be? 30, 41. Oops, it looks like something. Square root 41. That's the length of BC. We said, hey, but are we on the right track so far? Let's check it out again. Doesn't look so right, isn't it? 41, a prime number. Right. So when you feel a sense of suspicion, check it out again. So you look minus 1, moving to 3. Minus 1 to 3, it's 4 units. From minus 1 to 4 vertical distance, you got a 5 units. So 25 plus 16, it is 41. Yep. Now we look, so this length, let me just write it out here. Here, square root 41. Now we look at AC. AC, A, and C. A is minus 2 and a minus 5. And C is a 3 and a minus 1. From a minus 2 to a 3, minus 2 to 0, 0 to 3, that is a 5 unit. And a minus 5 to a minus 1. Alright, minus 5 going up to a minus 1. How many steps? Minus 5, minus 4, minus 3, minus 2, minus 1, 4 units. Alright, if you're not very sure how you can do that, if it looks minus 5, take away minus 1, you get a minus 4. But we're talking about absolute value for length. Ignore the minus, so that's a 4. Alright, so we said A, 25 plus 16, that's a square root 41. A, look at that length. We've got this length AC. AC is a square root 41. Got it? Wow. We can see it very clearly, isn't it, from this distance, that AC is equal to BC, and that is square root 41. Clearly spelled out, but you write your steps. I'm teaching you, so I'm just sharing with you. But when you write it out, please write down what is BA squared. Okay? So when these two sides are equal, what can we say? It's an isosceles triangle. Alright? Therefore, triangle ABC is an isosceles triangle. Isosceles triangle. Got it? Good. Alright? Now, we see the two lengths equal, and we can see it very distinctly by working out the lengths. Now we come to the next sum, the last sum for this practice. Alright, they want you to find the perimeter of this quadrilateral PQRS with vertices 2, 5, all these are given to you, and they want to find out the perimeter. Perimeter is just the length, alright, of the sides. And they want you to describe this quadrilateral. Is it a parallelogram? Is it a kite? Alright, is it a rectangle or a square? So this quadrilateral, if you have a kite, I just want to show you that a kite has got one isosceles followed by another isosceles triangle. But these two diagonals meet at 90 degrees. Alright, that can be a kite. A kite can also be a rhombus. A rhombus has all the four sides equal. Alright, and these two sides are parallel. Alright, and all the four sides are equal, but the angles are different. These two angles are equal. These two are equal. That's called a rhombus. If you have a rectangle, well, the corner angles are all 90 degrees. Right? And we know that they have a common midpoint, and they're both parallel. These two sides are parallel, and they're equal in length, the opposite lengths. As for the square, it's not very far off from a rectangle, and we know they're 90 degrees. Right? We need to show M1, M2, the product of the two gradients. If it's minus 1, it's already 90 degrees. That means they're perpendicular to each other. Alright, now they want us to describe it. Now let's get a mental picture of that to make it a bit easier. We said, hey you, what do you want? P is a 2, 5, 2, 5. We say, hey you P, 2, 5. Q is 7, 6. Alright, Q, 7, 6. Q here, 7, 6. R is 5, 3. 5, somewhere around here. R, 5, 3. Alright, 5, 3. And they say S is 0, 2. 0, 2 is X here. Alright, S, 0, 2. We're just drawing an approximate diagram. We're not going to be perfection in drawing. We're just getting a mental picture of what PQRS is all about. Alright, so that makes it a lot more easier. And we've got something like this in our diagram. And we don't know what it is. But if you did it a little bit more accurately, perhaps you may be able to see it. But we are not supposed to do by graphical methods. We are supposed to show that what they are. So find the perimeter. Let's get the length of PS. Alright, what's the length of PS? We do it again. PS. This is your S. This is your P. S is 0, 2. P is 2, 5. We want to find the length here. 0 to 2. The X, 2 units. From 2 to 5, 3 units. So 4 plus 9, 13. The square root of PS is square root 13. Now once we did PS, I'm just anxious to know what's QR. Let's draw QR. But we write here, hey you, your length is square root 13. Let's find out what is RQ. RQ. Let's look at it again. R is 5, 3. Q is 7, 6. Right? Drop the height. And is it from 5 to 7? 2 units. From 3 to 6, 3 units. Ooh la la! We see them equal. 9 plus 4, a square root 13. And you know what? You can also see the gradient. What is the gradient of this line? 3 over 2. Do you see that? Positive gradient. What's the gradient of this line? 3 over 2. They share the same gradient and they are equal in length. Got it? So that's one great point. So we said, we write it out. You know how to write that out, right? What do you say? Gradient of PS is 3 over 2. Gradient of QR is 3 over 2. So what does that mean? And the length of PS is equals to length of QR. You see that? Length of PS equals to length of QR. Oops, why am I writing M? What is length? Kumar, focus. Alright, let me erase that M and change it to the length. Alright, so the length of PS is equal to length of QR. And what is the length? We just found out, square root 13. Alright, now we want to find PQ because we need to find perimeter. But this already, if you have two sets of line which is equal, alright, in length and they're parallel, tells you that these two lines are going to form. When you join the four sides, it's going to be a parallelogram. Any line, for example, I draw this parallel to this line parallel, they're both parallel, they're both equal in length, just draw it and say, ooh la la, it's a parallelogram. You got it? Alright, so this already confirmed that this quad is a parallelogram. But we have not been over yet because we got to find the perimeter. My dear friends, we got to move on. All we need to do is find the length of PQ. And these two are equal in length. What's the length of PQ? PQ. P is 2 and 5. Q is 7 and 6. Alright, look at that. 2 to 7. 5 units, 5 to 6, 1 unit, 25 plus 1, square root 26. Right, are you happy there? You want to do one more? You like to be a little kiasu? This word, cute word, kiasu. Singaporeans will know it better. means we have a mindset, we just want to double check. It's quite a healthy mindset, all right? So let's look at the length of RS, all right? What is RS? RPM, sorry, yes, RS. RS, that's S and that's R, all right? S, R, this is 5 and 3, S, your 0 and 2. Look at from 0 to 5, 5 units, from 2 to 3, 1 unit. They are both the same. The gradient's the same. You can see it 1 over 5, 1 over 5. And they both have the same length, square root 26. Beautiful. Now, so we've got this very clearly defined. And if you got that with me, excellent, you're doing really well. And now the last part of it is the easiest part, the perimeter of this chord, all right? Perimeter of A, B, C, D is you just add square root 26, twice of it, right? Because you have 2 times, square root 26, square root 26, plus the length of the other one, square root 13. And there are 2 of it, isn't it? Isn't my writing terribly untidy here? 9 plus 4 is a square root 13. Yes, and 2 of it, square root 13. Got it? Now, you see a common thing related to this, all right? Well, that's 26. Don't ever take the 2 out and say, hey, no, that's square root 26 and that's square root 13. All you need to do is take out the 2 out, and if you think that this has got, if you look at it now, if I can write this way, square root 2, square root 13, plus 2, square root 13. Because square root 26 is square root 2, square root 13. You can take out the 2 and the root 13 out. Excellent. And what is left here is a square root 2 plus 1. You can write this way, or you can just put into your calculator and get your answer. All right? That's quite easy on that. So let's, you want me to do that? I'm sure you can fit into your calculator. That's the easiest thing. Now you would have found out that coordinate geometry, a simple picture when I drew it, gave me a mental picture that made maths a lot more easier. But if I did not draw this diagram, then I would have to look at finding out what's the length of PQ. The picture isn't there to assist, but you can still do it, all right? So if you're a very visual person, drawing it out will be good. Right, now you need a break. All right, look through what you've done, find out your errors, do your corrections, be a good girl, be a good boy. And then once you've done your corrections, have a good break before we come to the real challenge drill.